Okay, everyone, let's get started. So, welcome. Do a quick show of hands. How many of you love morning classes? So me and 2.5 other people, okay. So, in a certain sense, this is my first class at Douglas, because my real first class was an evening class, and I was not fully awake for that, so. And then the other class was canceled because of the evacuation yesterday. So this is my first semester teaching here. I was teaching at the U of A for about 1.5 years, so I did my PhD at the University of Alberta and got to move back here to BC where I'm from. And in fact, it's a little special for me because I did my undergrad in psychology right here at Douglas College. And I've had various little experiences that have convinced me that the education I received here is better than what I would have gotten at the big universities. You do get the status at the big universities, but I worked a lot with psychology undergraduates at the University of Alberta, and I don't even think the profs there would disagree with this. Profs at big universities don't care about teaching. It's publish or perish. All they care about is getting the research done. The profs in the psych department here actually care about teaching, so don't sell Douglas short. If you stick around here, I think you'll get a fine psychology education. Although, show of hands, how many of you are planning on being psych majors? I assume a minority. So maybe 6 or 7, okay. And how many of you, this is your first psychology class that you've ever taken? Maybe 30%. How many of you took 1100? That's like the normal way of doing it, but some people take this first. 1100 is not required, so if you didn't take it, you'll still be fine. So you can still get 100% in this course, even if you have not taken 1100. Also, show of hands, how many of you are on the wait list? Okay, one per. Okay, there's just one. Come see me after and tell me your name. You'll probably be able to get in. I try to show some preference for those who showed up. Apparently, I'm encouraged to not let too many in, but yeah, let me know your name at the end. I can't guarantee it, but probably will be able to get it. So I'll start with a little bit about me. So as I say, I did my undergrad here at Douglas College. I came in interested in philosophy and took a psychology course because I was interested in issues like philosophy of mind and thought that psychology might be relevant. Fell in love with psychology, did my BA here at Douglas College. I gave philosophy another chance. I did my master's in philosophy at Georgia State University, so lived in the United States for a while. And then for various reasons switched back to psychology for the PhD, which I completed this year at the University of Alberta. Since some of you don't know that much about psychology, I'll start off by saying that this class is about you all. You are all the subject matter. Psychology is the scientific study of the human mind and human behavior. So you will find points of connection to your own life, and I encourage you to reflect on those connections. It will make the material more interesting and also easier to remember. There are studies showing that if you can connect the information to other things you know or to yourself, it will be easier to remember. I think this puts us in an enviable position in psychology because we get to study what everyone's most interested in, which is other people. To fulfill a lab requirement, when I was here at Douglas, I took a geology course. Are any of you in a geology course? You're not missing much. So it's the scientific study basically of rocks. So it's the application of the scientific method pretty much to rocks. And the prof was an interesting character. He was showing us a picture of mudstone, and he stared at the mudstone for an uncomfortably long period of time before looking back at us and saying, "Isn't it beautiful?" So some people are like that, but most of us are not that interested in rocks. We get to study human beings, which as far as I'm concerned is much more interesting. So I'll give you a sampling of the kinds of topics we'll be covering in this course. Early on, we'll be talking about emotions and motivation. The following week, we'll be talking about how humans learn language, as well as different types of biases. So there's a section on human reasoning and some of the pitfalls of human reasoning. There's a whole chapter on intelligence and issues related to IQ testing. One chapter that a lot of students like is social psychology. So this is the psychology of human interaction. So we'll be talking about good things like empathy and romantic love, and bad things like aggression and racism. There's a chapter on personality tests and measuring personality. How many of you know the Myers-Briggs? We will not be doing that. We'll be doing a better one, more well-validated personality test. There's a chapter on the practical implications of psychology for things like stress, health, and happiness. And we'll conclude with 2 chapters that are probably on what most of you thought psychology was about before you took a course, which is psychological disorders and treatment of psychological disorders. Before we get to any of that fun stuff, today we have to cover chapter 2. So chapter 2 is also covered in 1100. It's on research methods and a little bit of statistics. We just assume that everyone who took 1100 repressed all of that information, so we will be going over that. Okay, let's start getting into the nitty-gritty. So, as with most of your classes, by the way, how many of you, this is your first semester at Douglas? Some people start in January. Okay, most. So, what I'm going to say, a lot of you will already be familiar with, but just in case, I'll start by talking about Blackboard. So, if you've not logged into Blackboard yet, you should do so. It's very important. Okay. So, there's a discussion board here called Course Questions. This is where I want you to put questions that pertain to everyone. So if you have a question about the course content, about the test, anything like that, put it there. I'll get a notification and I'll try to respond promptly. That way I don't have to say what an independent variable is 10 different times in 10 different emails. So that's where questions like that go. Obviously, if your question is specific to you, like about some medical incident that prevents you from being in a test or something like that, then of course send me an email. The syllabus is here. I'll come back to that in a second. We'll go through the entire syllabus just so you all know what's expected. This is probably the most important document on eClass, the key terms, especially based on how I teach this course. So this document should be your best friend. You should become close with this document. So it has the key terms that you should be focused on when studying for the test. I'd recommend having it out in class, either paper or on your computer, and you should be kind of jotting notes as you go through it. If you memorize these key terms, that is, I would say, 90% of your work as far as studying for the tests. I can't guarantee that every single question will relate to these key terms, but the vast majority will. If you know these terms, you'll be just fine. In my opinion, terms in psychology are not especially complicated. There's no calculus involved. There's just a lot of them to memorize. So please take advantage of this document. I also have here a PowerPoint you can use to study from or to follow along in lecture if you want. Personally, I don't like using PowerPoint. I find the temptation is too great to just read off the PowerPoint, and then it's like, well, why am I here? So I use the whiteboard and some video clips occasionally, but I do not use PowerPoint. If you feel you need something to follow along, this will sort of correspond to the order that I lecture. More so though, it's provided as something to study from. It will not cover every single testable idea, but it's kind of a crash course. If you're cramming before the test, you'll at least get the big ideas from it. The APA assignment, don't worry too much about that now. I will spend the beginning of a later class, I think after test 2, going over this in more detail. But the APA assignment is to teach you how to use APA style. APA citation style is a pain in the ass. And so I've decided to be nice. All you'll have to do is follow this template. You can literally download it and edit it to be your own. Just do what's in the template. When I taught at the University of Alberta, the average on this assignment was about 8 out of 10. As far as I'm concerned, there's no reason it can't be 10 out of 10. The only way you will lose marks is if you are creative with the formatting or with other things. No creativity. Just do what the template says. You'll probably get 10 out of 10 or 9.5 out of 10. I'll go into more detail when we're closer to I can't guarantee there will be enough of this for everyone, but if you participate in an experiment or a survey that's provided by honor students or someone else in the psych department, you can get up to 3% bonus. As I say, I can't guarantee there's enough of that for everyone, but I'm required to include that in Blackboard. Okay. Oh, we missed. That's okay. I will just edit that. So this is the attendance quiz. So we're a little past that. I forgot to make it so there's more room for this. But every day there will be an attendance quiz. It will literally be me just saying, press option 7. So it's just a way of keeping attendance. When we get to the syllabus, I will add that there is a way to not have to do it. If you can't make it to class for any reason, you're sick, you're tired of listening to me talk, it doesn't matter. Write a 300-word summary of some interesting things from the chapter. I won't be reading it super closely, and send that to me before class begins. No questions asked. So I don't want to force people to come, but I do want there to be a little bit of incentive and reward for people who put in the effort to show up. As you can see, this lecture is being filmed, so if you miss a class for any reason, you can just watch that and you'll basically be caught up. Okay, so let's start going through the syllabus. So some instructors are sticklers about names. You can call me David or Dr. Simpson, I don't really care. Maybe I should edit this out of the video in case other faculty watch this, but I always had a little bit of contempt for professors who insisted on being called Dr. So-and-so. I sort of thought, you teach at a college, one day you'll die, no one will remember you, it doesn't really matter. So whatever makes you comfortable. My office hours are listed here, so if you have extra questions that you want to ask about in person, you can come to my office. They're on the 3rd floor, north side of the building. If neither of those times work, just send me an email and we'll figure something else out. Okay, so this semester I'm teaching 4 classes, so it's over 120 students. Here's the bargain we'll strike with emailing. I am going to do my best to respond to all emails within 24 hours. Often I'll respond really quickly because I find it simpler to not let the emails pile up. So if I reply quickly, don't be freaked out. It's just that I got a notification and just wanted the notification gone. So that's my end of the bargain. On your end, before you send an email, please follow these guidelines. First of all, check the syllabus to see if the question is answered. Just use Control F and quickly find if that topic is addressed. I've tried to answer the sort of obvious questions in the syllabus. Additionally, like I said before, if the question pertains to everyone, so anything about course content or about the tests, please post that in course questions. But then, yes, if you have a question that pertains to you, then just use my email. If you can, try to remember to include Psych 1200 in the heading. That kind of makes it easy to see what kind of question I'm getting. And lastly, I strongly encourage in-class questions. The U of A actually was pleasantly surprised by how many I got, and in the classes where there were more questions, I found that made it more interesting. You will have questions about this material. It's about human beings, so I strongly encourage that. Now, I may have to cut it off. We are on kind of a tight schedule. It's basically 1 class per chapter, so if I think we're running out of time and have to finish something, I may say no more questions today, but if I do that, that means I'm very happy. That means there was a lot of engagement. Okay, the textbook is in the bookstore, lots of copies available there. So it's just loose leaf, so that makes it cheaper. There should be an online option too. Personally, I recommend getting the physical one. I was the kind of student who wrote up, underlined books and stuff like that. Some students many students are low on money and want to know if the textbook's required. Here's what I'll say. Technically, it is required. I can't guarantee that every single question on the test will be drawn from things I say in lecture. However, the vast majority will. what students have said to me in student reviews is they felt they were able to do fine just with the material in lecture. You may not get that A+, but you're all adults, you can do what you want with that information. I'm just passing on what students have generally said in student reviews. Okay, as I mentioned, I do not use PowerPoint in my lectures. I primarily use the whiteboard. I'll also show a number of video clips. This should be obvious, but I'll say it anyways. If I show a video clip of someone, that does not mean I endorse every single thing they have ever said. Should be obvious, but I'll add that caveat. So as you can see, the lecture is being filmed. I mentioned this when people were coming in, but just as a general note, if you're in the front row, kind of these people here, you will be on YouTube. A little bit of, well, very little YouTube fame. So this allows you to re-watch lectures if I was talking too fast or you missed something or just want to review it. The only thing that will not be on the YouTube video is the clips I show in class. I'll edit that out so it doesn't get removed for copyright reasons. So for that, you have to show up to class. Here are two optional extra resources. Hank Green's Crash Course Psychology, and if you use Crash Course in your other classes, that's a great resource. And Paul Bloom's lectures at Yale, if you have no life. So, I didn't emphasize this as much in the Monday class, but this semester you'll find will go by pretty fast. So there are 4 tests, and typically there will only be 2 or 3 classes before each test. So the first test is not that far away. There's this class, next week's class, and then the first test. Now, the fact they're spread out like that does mean they're worth less. Not worthless, but worth less. Less percentage points, so they're not super high stakes. With the exception of the cumulative final, the first 3 tests will each be on 2 or 3 chapters. So you'll get a good sense from the first test of how difficult the content will be. It should stay pretty consistent. I've added an extra day before each test. This is in a different room. It's N2201. This is that big room across from the library on this campus. So that's on Fridays, 2:30 to 4. If you can't make it that day, it's okay. That will also be filmed and put online. So that's an optional day where you can come and ask any last questions you have on the content for the upcoming test. So on every Friday before a test, that's available as well. On one day we're not meeting here. On April 10th, which is a required normal class day, we'll be meeting in the psych lab. We're required to have a kind of activity day, so on that day you'll be given some cases of psychological disorders and be asked to diagnose them. So get to put your knowledge of the disorder chapter into practice. And you will receive a grade for that. I won't be grading it, the lab people will, so make sure you come to the right class for that. Okay, I've already been through a lot of content. Any questions on anything in the syllabus so far? Okay, I have 4 study tips here. The first one is test yourself, especially on the key terms. So they've actually done experiments on this, where you get a group, randomly assign them to 2 conditions. In one condition, the group reads something twice. In the other condition, they read it once, but then get tested on it. Bring them back in a week. The second group does better if you test them again. Testing yourself on the material strengthens your memory of it. Additionally, and maybe more obviously, it shows you what you don't know. It's easy to lull yourself into a false sense of security when you just reread something. But if you get those key terms out, and here's what I would do in undergrad. I would have a list of key terms. I would get into a room where no one could hear me and just say definitions out loud. And then sometimes I would hear myself not make sense, and I actually don't understand this. So I would have two lists of the key terms, one with the definitions you've written and one with just the terms. Take that second list, say as many out loud as you can and see where you fall short. If you get to a point where you can say them all out loud, you're pretty much ready for the test. Next one, also supported by research, categorize the information into chunks or categories. That makes it easier to handle. The third one, I'm stealing from another prof in the department, actually another David Prime. I did an honors degree here, so I wrote an honors thesis, and David was my supervisor. So, very cheesy joke, everyone called us David Squared. So he teaches cognitive psych here, and he would always say this, don't focus on memorizing the ideas, focus on understanding them. Just repeating it to yourself and trying to get it into your head is less effective than just trying to process it deeply. Trying to think about what it means, try to connect the ideas to other things you know. If you do that, the memorization will kind of come along for free. And lastly, if you're struggling, try to expose yourself to the ideas multiple times and in multiple ways. So come to lecture, have a look at the book, use the PowerPoint notes that I provided, maybe look at the optional video resources. If you're struggling with something, maybe hearing it said a different way may help. Okay, here's the grade range. Okay, this is underlined, so I'll say it now, emphatically. There will be no changes to final grades based on student requests at the end of the semester. In my opinion, it isn't really fair for you to get a better grade just because you're better at writing a sad email. So if you write me an email saying, oh, Dr. Simpson, I got a B+, and I'm only 0.6% away from an A-, and if I don't get at least an A-, my mom won't love me anymore, and oh, can't you just bump it up? If you write an email like that, I will not grant the request. If you have a concern with a specific thing that's been graded, you're welcome to let me know about that, but saying something about, oh, I'm so close to X grade, I'm not going to grant the request. So just do your best in the course, starting now, and let the chips fall where they may. One other thing I'll say, a lot of first-year students, I don't appreciate how true this is. Little changes like that make no difference to your final GPA. And if you don't believe me, you can have some fun. Click on the GPA calculator link and enter 40 grades. You'll need 40 courses to get a bachelor's degree. Enter a bunch of random grades and change one from a B+ to an A- and see what happens. Nothing will happen, right? So it doesn't matter. So that's, I just want to say that up front. Okay, here's the breakdown of grades and the relevant due dates. So as I said, at the beginning of every class, there will be an attendance quiz. This is to provide some incentive for showing up. The lecture is being filmed, so you don't have to show up to get the information, but in my opinion, it's better to learn in person. It's all too easy to scroll through other things while you're listening to a lecture on a video. So I do want to reward people for coming to class, but as I said, if for any reason you can't make it to class, you can send me a 300-word, which is just like one page, double-spaced, not very much, summary of what you learned from the chapter for that day. And if you really want, you could do that for every class. I won't ask any questions, so you have that option. For the tests, the way the tests work is each one will have about 20 questions per chapter. So test 1, 40 multiple choice, 20 from each of the first 2 chapters, 1 written. Only tests 1 and 2 will have a written, and for those I will basically tell you what the question is in advance. So you should come ready to answer that. The APA assignment, as I say, we'll talk about that more on a later date. Tests 3 and 4 have no written, and test 4 is a cumulative final. The first 30 questions come from the entire first, 3/4 of the class, and then 40 questions come from the final 2 chapters. It's more from the final 2 because For the rest of the book, you're basically being tested twice. So if you do the math, it works out. Okay, so you will have just shy of 3 hours for each test. This should be much more than you need. At the U of A, it was 1 hour and 20 minutes. And virtually everyone finished a little bit before that without any issue. Some students need accommodations, like extra time. This should take care of most of that. This should be much more time than you all need. So for the test, you'll have to bring a pencil for the Scantron and your student ID. Okay, any questions on grades? So APA assignment we'll come back to another day. The bonus, as I said, there's you can get credit for doing studies with the psych department. Okay, missed tests. Here's my policy. If you let me know far in advance that there's going to be some kind of scheduling conflict for a test, I'm probably just going to take your word for it. So if you know now that you're going on vacation or have a family event or something on the day of a test, let me know now, and I'll, as I said, probably just take your word for it. If you email me right before a test, like a day or two before a test, I'm going to require some kind of documentation. So doctor's note, something like that. So then I will be more strict. Use common sense. Another prof in the department, Brian Nadeau, told a story about this. He gave a spiel similar to the one I just gave about giving documentation. And he made the observation that around midterms, grandmas drop like flies. At midterms, for some reason, lots of grandmas die. And so he said, look, I hate to do this, but I do need some kind of documentation. He went to his mailbox and got a note saying that a package had arrived that was too large for the mailbox. He went down to security. The student had sent his grandmother's ashes to this prof to prove it. So please don't do anything like that. Picture of a death certificate or something. That was fine. Okay, last thing. At the University of Alberta, I once saw the following complaint on Reddit. Here's what I'll say. Look, I was once an 18-year-old male, we are all mammals, we all produce a scent. I'm not judging, but just a friendly reminder, this is a small classroom, so shower, use deodorant, all that good stuff. And I have a little note here that if you're thinking, no, my natural scent is pleasant. If you think that, you probably need to shower more than anything. Okay, that's all I have to say for the syllabus. Any questions about any of that? Okay, so as I say, we still do have to cover content today, so we're going to finish chapter 2. We'll have enough time. So for some of you, this will be a review, but it's important review. And at some point, I will give us a break, kind of a natural stopping place. But before chapter 2, I'll start at the very basic level. What is psychology? So if you look at the etymology, it comes from the words psyche and logos. Psyche meaning mind or soul, and logos, strictly speaking, means word, but it can mean study of or discourse about. So psychology is the scientific study of the human mind and human behavior. A crucial word in that is scientific study. Psychology, at least we try to be scientific. Relatedly, this means that psychology is an empirical discipline. Anyone from 1100 or another course tell me what empirical means? So empirical means based on observation. So based on what you can detect with your five senses. This makes psychology different from philosophy. Now, I did my master's in philosophy, nothing wrong with philosophy, but philosophy is not typically based on observation. It's based on reason. Philosophers do ask some related questions. They ask questions about the human mind and human behavior, but they argue about them. They use purely conceptual or rationalistic discourse. They don't do experiments typically. In psychology, well, we try to be an empirical discipline. Additionally, psychology studies human behavior at the individual level of analysis. This makes it different from a field like sociology. How many of you are taking a sociology course? Anyone taking a philosophy course? Okay, actually more than the Monday class. So sociology studies human behavior still empirically, but at the group level of analysis. So take racism as a subject. Psychologists will get samples of people or groups of people into the lab to study, but what they're interested in is what people believe, how people feel, so it's all, as I say, at the individual level of analysis. Sociology would study racism as a societal or structural kind of thing. I'm not saying either one is right or wrong, they're just different levels of analysis. Though, in a field like social psychology, the line might be a bit blurry. Okay, another thing I'll say about psychology is in the standard scientific picture of the world, it has a particular relationship to the other sciences. In the standard scientific picture of the world, psychology is ultimately reducible to biology, which in turn is reducible to chemistry, which in turn is reducible to physics. What do I mean by that? So think about psychology. As I said, it studies the human mind and human behavior. What is it that enables us to think and behave in the ways that we do? Mostly, it's the 3 pounds of meat between your ears. Right? It's the brain. In 1100, of course, you learn about the brain in more detail. Other parts of the body are relevant too, say for different emotions, there's often a bodily component, but all of that, the reactions in the brain and the body, all of that is the purview of biology. Now, it's too hard to study every neuron and every action potential when you're studying emotions, for example, so you study it at a more zoomed out level of analysis. So psychology is basically complicated biology, studied from a zoomed out or more coarse-grained perspective. Now, what's biology? So think about the study of the brain. The brain is really just a bunch of chemical reactions. If you remember 1100, it's sodium and potassium moving through voltage gates. That's what enables the brain to do what it does. But neuroscientists don't have the time to study every single sodium ion. That's too hard, even though ultimately it is a bunch of chemical reactions. And then chemistry is basically just applied physics. It's just particles obeying the laws of physics. So that's, in the standard picture that you get from science, the relationship of psychology to these other fields. So why do we need a science of the human mind? Many of us have intuitions about how humans work from life experience or from tradition. Why can't we just trust that? And there are different answers. One answer is we are not as smart as we think we are. science really grows out of an awareness of human limitations. It's a way of giving ourselves reality checks, of forcing us to try to test our ideas and not simply take ideas on faith. It's worth remembering how limited we are. We are genetically more closely related to chimpanzees than Asian elephants are to African elephants. So it's quite impressive we've gotten as far as we have, but we should not just trust our instincts or intuitions. There's one particular kind of limitation we have, which is confirmation bias. So how many of you saw this in 1100? So confirmation bias is the tendency to seek or interpret evidence in a way that favors the beliefs you already have. We all have beliefs, and what we will tend to do is look for evidence that confirms the beliefs we have, or if we're given evidence, we interpret it in a way that confirms what we already believe. Here's a nice comic that shows this. I've heard the rhetoric from both sides. Time to do my own research on the real truth. Literally the first link that agrees with whatever you already believe, and of course, jackpot. The way that science combats this is it emphasizes putting forward theories that are falsifiable. Falsifiable means able to be proven wrong. So what I'm about to say is a bit of an oversimplification. When I was at the University of Alberta, I taught a course on philosophy of science and philosophy of mind in connection to psychology. But to a first approximation, scientific theories are marked by being falsifiable, being able to be proven wrong. And that might seem strange. You might think if a theory is unfalsifiable, like it can't be proven wrong, that's good. That means it's like indestructible. Nothing can prove it wrong. But in fact, it's not good. Theories that are unable to be proven wrong, that means that there's no test you could run on it. So one example of a good scientific theory in this regard is Einstein. This is kind of the one you'll see in the philosophy of science textbooks. So Einstein's theory posits, among other things, that gravity can curve the fabric of space. And it was a very bold idea. It solved certain problems in physics. But it leads to a testable prediction. So let's say this is the sun and this is the earth. Let's say there's a distant star here. It means that the light from the star should be curved around the sun. Now normally you can't view the stars when the sun's out for obvious reasons, it's too bright, but you can during an eclipse. So Einstein's theory leads to the prediction that if you view stars near the sun, when there's an eclipse, the starlight should appear here instead of here. If the starlight is not here, Einstein's theory is wrong. So the theory sticks its neck out, right? It makes a risky prediction that can be proven wrong. So that's very crucial to how science works. And as we'll see, some theories in psychology, it's been argued they're not falsifiable, and that counts strongly against their scientific styles. Okay. Any questions on that preamble? Okay, now we'll get started on chapter 2. Normally when I go through a chapter, I go in order, but there's one set of concepts from chapter 2 that are so important, I'm going to move them to the beginning. Nudge, nudge, hint, hint. He's saying they're very important, and he's moving them to the beginning. So here's what I want you all to do. On a piece of paper or on a computer or tablet, whatever, write down 2 numbers. The first one, how many sports you played in high school. And the second one, how extroverted you think you are on a scale of 1 to 7. So extroversion means, you're outgoing and socially confident. Okay, so 1 would be low, 7 would be high. Two numbers. How many sports you played in high school and how extroverted you are. Okay, so I'm not going to ask you for your data, but what I could do is get all of your scores and locate all of you in this two-dimensional space. So where the x-axis, the bottom, is how extroverted you are, and the y-axis is how many sports you played. So let's say someone was really high in both, so they played 5 sports in high school, and they are a 7 on extroversion. So they would go right there. So the point here corresponds to a person who is high in both. Now I'm just going to make this up, but let's say it looks something like this. This would be an example of a correlation. This is a very important term. A correlation means that two variables vary together. In this case, this is a positive correlation. Positive correlation means as one variable increases, the other variable increases as well. Whereas the book says more is more. The higher you go in one, the higher you go in the other. A negative correlation means as you go higher in one variable, you go lower in the other variable. Or more is less, as the book says. I don't know for sure this is true, but perhaps video game usage, let's say hours of video games every week, and GPA may be negatively correlated. On average, people who play more video games per week may have a lower GPA. So that's what a correlation is. We'll come back to it later in the chapter, but for now, let's just look at this example here, this correlation between extroversion and sports. It's very tempting to look at this scatter plot and make the following inference. It's tempting to think, this must mean that playing more sports causes you to be more extroverted. My son Timmy is kind of shy. I should get him to play more sports. This will make him become more extroverted. Of course, if you've taken 1100 or another science class, you should know that's a bad inference. This is probably the most important thing that we teach in intro psychology because it applies to any other science. If you want to get a tattoo, tattoo this on your forehead. Correlation does not imply causation. Correlation does not imply causation. If two variables, A and B, are correlated, that does not imply that A causes B. Why not? So, anytime A and B are correlated, meaning they vary together, there are 3 possibilities. One is that A causes B. That is one possibility. If playing sports did cause extroversion, that would explain this relationship. It's just not the only possibility, so you can't jump straight to this one. Another possibility is that B causes A. It could be that being extroverted causes you to play more sports. Maybe outgoing people seek out more sports because there's more people there, whatever. Possible. And 3, it could be that C, and C here just means any variable you didn't measure, causes both A and B. So there could be some third variable that you didn't measure that causes more extroversion and more sports playing. And you could make up all sorts of possibilities. Maybe income. Maybe rich kids are more outgoing. Their richness makes them kind of arrogant, and they feel confident in approaching people, and their parents have more money to put them in more sports. I just made that up. I have no idea if that's true. But the point is, you can't rule something like that out based on the data here. You can make up other possibilities too. Height, maybe tall kids are more extroverted and they play more sports, whatever. You can make up all sorts of stuff. So, can't infer causation from correlation. But that's kind of sad because we want to know about causation. We want to know about which variables cause other variables. Partly because this is just scientifically interesting, we want to know about cause-effect relationships, but also because they're important for intervention. Part of the point of science is to know how to intervene in the world, and if you know about cause and effect relationships, you can make advice like the following. If you're shy and want to be more extroverted, you should play sports, because then you'll become more extroverted. You can only make a recommendation like that if you know about cause and effect relationships. So, how do we provide evidence for a causal relationship? What's the magic word from 1100? Any 1100 students? Starts with an E. Or you engaged in some Freudian repression, just repressed all of the 1100 information. So the magic word is experiment. If you want to provide evidence of a causal relationship, you do an experiment. So, in psychology, when we do an experiment, we get a sample of people. The crucial step is random assignment. You randomly assign people to 2 or more conditions. We'll start with 2 just to keep it simple. The reason random assignment is so crucial is in an experiment, what you do is you want to hold all variables constant and then change one variable and see what happens. The way we do that in psychology is random assignment. If we get a big group and randomly assign people to 2 conditions, these 2 should be basically the same. There should be roughly the same number of tall people, rich people, happy people, or what have you. And then what we're going to do is do something to one group that we don't do to the other. And then we can infer that any differences that result come from the thing that we did. So to make it concrete, let's say we make this group do 5 sports for 6 months, and the other group 0 sports. No sports for you for 6 months. This is the independent variable. The independent variable is the one that we manipulate or control. So sometimes called the manipulated variable. So we're going to make it so that this group does the sports and this group doesn't. And then, and by the way, if you ever can't read a word I write, just let me know. I know I have messy writing. There has been progress though. In kindergarten, my writing was so messy, they would give me a dotted line to trace for like my name or different things, otherwise it would be not legible, so there has been some progress. my English teacher gave me kind of a backhanded compliment in grade 12. He said, his writing is very hard to read, but usually worth deciphering. Okay, kind of a compliment. So that, then at the end we'll measure extroversion in each. The variable we measure at the end is called the dependent variable. Now, let's say that at the end of this, and you probably wouldn't get an effect this big, but let's suppose that the average extroversion score on a scale of 1 to 7 is 5.5 in the sports group and 1.6 in the zero sports group. Now, you would have good evidence that playing sports causes extroversion. Because of random assignment, that's the key step. These groups should be roughly the same at the beginning. The only thing that's different is this group played 5 sports and this group didn't. And at the end of it, this group is more extroverted. And by the way, forgot to say this. If you want an easy way to remember the difference, because obviously the words are very similar, think about it like this. If your hypothesis is right, the independent variable will cause a change in the dependent variable. Right? That's the idea you're testing. If that's right, the dependent variable depends on the independent variable. Right? If one thing is the cause and the other is the effect depends on the other thing. So that's one little memory trick for keeping them distinct. Any questions on the logic of an experiment? Okay. Now we'll start going through the book in order. Okay, so the first term that the book uses, which relates to another term I've used, is empiricism. So this relates to the word empirical, which in turn relates to the word observation. Empiricism, in this context, means that the only way to acquire reliable knowledge about the world is through observation. So this is will start out as a philosophy, but it's a philosophy that influenced the scientific method, influenced kind of scientific worldview. So you'll remember earlier I said that science is all about giving ourselves reality checks. And I'll actually show a video of a physicist spelling this point out in more detail. Okay, well said by Carol. In the same section, it distinguishes between theories and hypotheses. We'll actually start with hypothesis. So, a hypothesis is a specific, testable statement. So, hypotheses typically, though don't always, follow from a theory. A theory you can think of as a kind of network of hypotheses. It's a set of ideas that are logically related that explain a large body of data. So a theory is a set of ideas logically related that explain a large body of data. So think of the Einstein example. Relativity theory, right, is a set of ideas that explain a large body of data. The statement that the starlight should be here rather than here, that would be an example of a hypothesis. It logically follows from Einstein's theory. You can think of Darwinian theory, right? Like Darwinian theory of evolution is not a single statement, right? There's a whole set of ideas. But if you go into the field to dig up some fossils or something, you have an idea of what you're going to find. That specific claim about what you're going to find would be a hypothesis. So we've talked about different virtues of science. We've talked about how it's empirical, for example. Another virtue in science is precision. We want to be as precise as possible. This is difficult in psychology. It's one of the most difficult issues in psychology because many of the variables and concepts that we are interested in are not easy to define. There's great disagreement and debate about how to define terms like happiness, intelligence, and so on. So what do we do? What's our solution? The solution is we give operational definitions. An operational definition is a specific, measurable definition of a concept. So let's take intelligence. So there's debate in psychology, philosophy, etc., how to define intelligence. We don't want to write a scientific paper that has a bunch of conceptual debates. We want to test something empirically. So what we do is we say, for the purpose of this paper, we are going to define intelligence as an IQ score. Because that's specific, measurable, public, everyone can agree on the result of a test. Now, we know IQ tests are not perfect, like any psychological instrument. There's controversy about them. But when you're writing a paper, you do have to operationalize your variables. So that's one common way of defining intelligence. We already did this earlier. Here's an even simpler case. There's debate about the term extroversion, but for our little fake study, we operationally defined it as your score on a scale of 1 to 7. Right? Precise, measurable, etc. Now, not all operational definitions are created equal. The kinds of tests we use in psychology, we evaluate them in two main ways. In terms of validity. Now, there's different senses of the word validity in psychology. Here, I mean construct validity. And reliability. I'll actually start with reliability. So, reliability relates to how consistent a test is. How consistent are the results you get from a test? So let's say I give someone an IQ test in January and they have a score of 112. They come back in March and they have a score of 110. Okay, that's pretty reliable. By the standards of psychology, that's pretty consistent. If I give the IQ test in January and they have 63, they come back in February, they have 149, bad test. Right? That would be low, very low reliability. But reliability alone is not sufficient. Here's a silly example. Suppose I want to become famous and I invent a new IQ test. And here's my IQ test. I measure the length of your left pinky toe in centimeters, and that's your IQ score. That would be a fabulously reliable test, right? Unless you have a terrible accident, it's going to be the same IQ score pretty much every time. What it would lack is validity. Validity is the test measuring what it purports to measure. So in that case, I'm claiming the test measures intelligence. Clearly it doesn't. So that's what validity is about. Validity is a much more controversial notion. There is disagreement about how best to get at validity. Here's one example that we'll talk about this more when we get to the IQ chapter, where the debates are probably most intense. But one example of validity, a way of getting at validity, is criterion validity. So criterion validity is, does the test correlate with something that it should correlate with? So for example, if IQ tests are valid measures of intelligence, they should correlate with grades. Not perfectly, but there should be some positive correlation. If the correlation is 0, okay, you're not on firm footing saying that these are measures of intelligence. There are other ways of getting at it too, but that's one example. Okay, there are different pitfalls when we're doing psychology experiments that we want to avoid. I'll go through a couple of those and then we'll take a break. So one issue is demand characteristics. Or just before that, any questions about these terms? They're very important. Okay. So demand characteristics are anything in an experiment or lab situation that makes a participant think they know what the hypothesis is, and it may cause them to change their behavior. They may think, oh, I'm going to be nice, I'm going to do what I think this scientist wants me to do. Another issue that's somewhat related is social desirability bias. This is a bias towards responding in a way that you think will make you socially desirable. So you're trying to get people to like you. So as you have all, actually I guess before I say that, this is especially a problem when we use self-report. So very often in psychology, if we want to know, for example, how extroverted someone is, we just ask them. We're saying with, how happy are you? We just say, how happy are you on a scale of 1 to 7? As you all know from being alive, people are not always 100% honest. And one particular kind of dishonesty is trying to answer in a way that makes you look good. There are different ways to control for this. One that we'll see in the personality chapter is you can give people different kinds of lie scales. So you include random questions throughout the study where the socially desirable answer is true of almost no one. So something like, have you ever done something you're ashamed of? You say no. Okay, maybe, but, or have you ever missed a day of flossing in your life? Never. You include 5 questions like that. If they give the socially desirable answer to all of them, you may take their data less seriously. They're probably trying to just make themselves look good. One way to avoid some of these issues, although this method has its own problems, is to do naturalistic observation. So typically in psychology, we do studies in a lab. We bring people in, we give them course credit or whatever. Naturalistic observation means you observe people in their natural environment, if you like. go to a mall or a school. Well, if you go to a school, get permission from the school first. And you just observe people and try to pick up on patterns. So then people don't know they're being observed. You just sit there unobtrusively, and this can be a useful way of gathering data and generating new ideas. Probably you won't get this published if you do just this and nothing else. You'll probably want to use it more as a kind of idea generator. You may want to test it later with something more controlled, but that is one method we use. Okay, last issue before taking a break is observer bias. I'll talk about this and then solution. So observer bias is where the experimenter has a bias or an expectation, and this influences the behavior of the people in the experiment. So this is an issue with the experiment. I'll make this really concrete. Let's suppose I have a new antidepressant. I want to reduce people's depression. And let's say these two up front are both in the experiment, and this person I give the real drug, and this person I give the placebo. So as you know, drug trials, you have like a sugar pill or something. If I know who's in which condition, consciously or unconsciously, I may treat this person better. Here's your antidepressant, hope you're doing better, I'm seeing some improvement, and I give you, and it may not be on purpose, but my expectations may influence how they behave. This person may become more sad as a result, and then it's not really a result of the drug, it's a result of, my subliminal cues that I'm not so optimistic about how this person's going to do. Anyone know the term for the solution to this? Yep.
A double-blind study.
Exactly. So a double-blind study or double-blind trial. So single-blind means they don't know if they're in which condition they're in, if they're in the drug condition, placebo condition. Double-blind means the subjects don't know which condition they're in, and the experimenter doesn't know who's in which condition. A lab rat in the back, obviously, who's running the numbers will know, but no one who interacts with the participants knows. Okay, any questions before a break? Okay, come back at 10:55. Okay, so we'll pick up where we left off. The next concept we have to explain is sampling. So, a few terms here. So, the population is the group you're interested in, and it's the group from which you'll take a sample. So, let's say the population is all Canadians. It doesn't have to be the population of the country. Your population could be all humans, it could be all males, whatever, but let's say the population we're interested in is Canadians. It's too hard to study all Canadians, so we'll take a sample. We want a sample to be representative. Representative means similar to the population in terms of demographics. So if the population is 50% male, you want the sample to be roughly 50% male. If the population is roughly 10% seniors, you want the same to be true the same. So how do we make this happen? The easiest way is, common way is random sampling. Although, I should say, in psychology, actually not all that common. We often use convenience sampling, but don't worry about that now. Random sampling is where you have something like a phone book or some other list of people in the population, and maybe a random number generator or something else to pick who's going to be in the sample. Typically, that makes the sample roughly representative. Please do not confuse this with random assignment, which I talked about earlier. Random sampling is about choosing people to be in the study, in the sample. Random assignment, you already have the people in your study, and you're randomly putting them into 2 or more groups for the experiment. Maybe the antidepressant group and the placebo group, or whatever. Or the high sports, low sports. So keep those distinct. Random sampling is not the only method of making it more representative. A more straightforward way, which I did in one study when I was in Georgia State University, is to use stratified sampling. With stratified sampling, you force it to be representative. You set cutoff numbers for different demographic groups. So in the study I was a part of, we stratified by age and gender. So once we had whatever it was, 200 males age 40 to 50, no more males age 40 to 50. So that's the way of just setting it up in advance so that it will be representative. Any questions on that? Okay, once you have your sample and collect data, there are different ways of summarizing that data. One thing you can do is a frequency distribution. And there's a particular way that frequency distributions often look, which is something like this. I'll pick IQ, we'll be talking about it later. If you set up a frequency distribution, on the bottom is different scores, so ranging from, let's say, 70 to 130. And then the y-axis is how many people are at those different scores. And what it would look like is something like this. With most people being close to the middle, and scores becoming less common as you go out to the extremes. There's actually an equation for a curve that runs through this. This is not exactly what it will be, but it's a good approximation. Does anyone know the term for this type of distribution?
Bell curve?
Yeah, bell curve or normal distribution. It's called a bell curve because it looks kind of bell-shaped. So many human traits look roughly like that. The book says, if you'd like to remain single for the rest of your life, you can tell everyone that you also know that it's called a Gaussian distribution. I felt personally attacked by that. I told a class I taught at the U of A that I've given thought to an alternative career. Do any of you know, you all might be too young, but the It Gets Better campaign from like the mid-2000s? A couple of nods. So it was a campaign that people in the LGBT community started. They'd have people who grew up in homophobic homes say that, look, it was hard to come out and your teens may be difficult, but it gets better. I've half seriously thought about starting something like that, but for straight nerds. Just to say to guys, hey, it gets better. It's not. So that's frequency distributions. There are 2 other important properties that distributions have that we'll talk about, or 2 different types of data. One is central tendency, and the other is variability. Central tendency is about where the scores tend to be, or you could say where the middle of the distribution is. There are 3 measures of central tendency. The mean, the median, and the mode. The mean is the same as the average. Presumably you all learned how to calculate the average, many years ago. Just take the scores, add them up, divide it by the number of scores. By far the most commonly used measure of central tendency. So why would we use anything else? You may think, why don't we just stick with that? There's a downside of using the mean in some contexts, which will be clear in this example. Let's say I'm looking at different villages and how much money people have. I find one village and it has 5 people. 4 of them have $0, no money. And one dude has $1 million. The average amount of money per person in this village is $200,000, right? So let's say I'm going to the relief agency and I say, this village, doing pretty good. No aid needed here. The average net worth is $200,000. That would be true, but it would be misleading, right? This is the main weakness of the mean, is it is sensitive to outliers or extreme values. If there are very high or very low values, they can substantially affect the mean. In cases like that, you will typically use the median. The median is the middle score after you rank them from lowest to highest. So take all the scores, rank them from lowest to highest, pick the middle one. If it's an even number of scores, you pick the middle 2 and average down. If you look up average income in Canada, you will have to look very hard to find the median. Typically the median is reported, and it's because of this issue, right? There's a few billionaires, right? And they drag the mean up. For that reason, typically the median is reported. And then the last one, the mode, is the most commonly occurring score. As an aside, in a perfectly normal distribution, or as close to perfect as possible, these 3 will be the same. So just to make it really concrete, let's say that there's a different village, one guy has $1, one guy has $7, next guy has 110, and then 3 people have $300. I'll just say 2, whatever. 2 people have $300, 300 is the mode. That's kind of a strange case, but that would be the mode in that case. Any questions on the 3 measures of central tendency? Okay. Nothing too fancy there. Okay, the other measure, type of measure we care about is variability. Distributions differ not only in central tendency, but also in variability. So here's a simple case. You could imagine 2 classes, one where, or both where the average is 70, but in one, they're all between 67 and 72, and the other, they range from 50 to 100 with lots of spread. And that would be a difference. So that's what variability has to do with, is how spread out the scores are. The simplest measure of variability is the range, which is just the biggest score, subtract the smallest score. So God forbid, suppose the grades in this class range from 100 to 1, the range is 99. Hopefully it doesn't happen, but that would be the range, so 100 minus 1. The more commonly used measure is the standard deviation. So I'm going to define this in two ways. First, I'm going to give the definition that's good enough for a test in this class. Good enough for the intro level. And then for fun, for me, if for no one else, I will show you how to calculate it. If you go on to take Psych 2300, this will be useful, but if math traumatizes you, you can just turn your brain off while Excel is on the screen. But for the test, I'll give you this definition, which is not quite right, but it's good enough. It'll give you an intuitive sense of what's going on. The standard deviation is roughly how far away, on average, are scores from the mean. So some scores are close to the mean, some are very far from the mean. Okay, but how far away on average are scores from the mean? So in the case of IQ, for example, the average is, does anyone know what's the average?
100.
100. So it's set up so that the average is always 100, and the standard deviation is 15. Some people will be far from the mean, so 140, whatever. Some will be close to the mean, but 15 is how far away on average they are. Okay. So that's the definition that's good enough for the test. Any questions on that? Okay. Now me and two nerds will have fun. So if you go on to take a statistics course, this is how to calculate it. It's actually not too bad. So let's say this is a set of grades for a course. And so first thing we do is calculate the average. Okay. And now I will subtract the average or the mean from each score. So this minus the mean, that's the deviation for log. And that should look right. Nothing too fancy there. Bob is 17.1 points below the mean. Okay, let's do the same for all these. Now you might think, this will be easy. We can just average these numbers. Well, let's try just adding them first. It's 0. And when you think about it, that has to be true. Because they'll cancel out. Because how far away are scores from the mean on average? Well, on average, they are the mean. So what we have to do is make them all positive. So then we can work with it. So the way we do it is we square them. So we'll square them, average them together, and then square root it to get it back to a normal size. So this raised to the power of 2. Do that for all of these. So now we have the squared deviations. We'll get the average of that. Okay, now that's way too big because squaring makes it larger as well as making it positive. So then what we do is we square root this, voila. So that, in this example, is the standard deviation. And that should look right. You look through, yeah, some are close, some are far away, but how far away are they from the mean on average? Around 10. So if you go on and take statistics, that's how it's done. If that gave you a headache, you can repress that information. And there are real cases where it's important to keep measures of variability separate from measures of central tendency. One real case that we'll see later in the chapter. Some studies find, well, first of all, virtually all studies find that the average IQ for males and females is the same. But some studies find the variability is different. So you'll find in some studies that the male distribution is wider, meaning more at the high end and at the low end. So that's an example where knowing the difference matters. Okay, now we're back to correlation. So we've already talked about this, but I'll add some more information. So We already talked about how correlations can be positive or negative, but they can also vary in strength. So when we quantify correlations, they range from -1 to 1. 1 is a perfect positive correlation. And for convenience sake, we'll just focus on linear correlations. Right. You can have correlations where a straight line is not the best approximation. For example, you might find a correlation like this, where it's a curvilinear relationship, but don't worry about that at this level. We'll just focus on linear relationships. So if the dots are all exactly on that line, the kind of line of best fit, that would be a correlation of positive 1. A correlation like this, so they're pretty tightly clustered around the line, but there's some spread. I would have to calculate it, but that might be 0.8. Right, pretty strong. One way to think about what it means to be strong is, if I know someone's score on this variable, I can predict with pretty good accuracy what their score will be on the other variable. Something like this. Okay, now there's more spread. Maybe 0.5. You need a little more information. A correlation of 0, the line will be flat, and the dots will be all over the place. In a case like that, if I know what your score is on this variable, I have no information about what your score is on the other variable. I used that silly example earlier of the pinky toe. Pinky toe length and IQ, probably no correlation. Okay, same thing with negative correlations. If they're all perfectly on the line, that would be a correlation of -1. So basically, correlations are, the stronger they are, the further away they'll be from 0. And then -0.8, So here's a gift. On the test, there may be a question where you have to look at scatter plots like this and be able to tell, are they positive or negative, and which one is stronger. If you understand what I've said here, they won't be close calls. So basically, tightly clustered around the line, stronger correlation. Pointing down, negative correlation. Pointing up, positive correlation. And the stronger they are, the further away they are from 0. Any questions about that? Okay, we've already talked about experiments, but to hammer that point home, I'm going to show a video of Hank Green talking about how to do experiments in psychology. So he added some good terms there. So one that I didn't use, but that video helps with, is experimental group and control group. So experimental group is the one that gets more of the independent variable, and the control group gets less of or none of the independent variable. So in that case, decaf versus a moderate amount of caffeine versus a high amount. Okay, when it comes to experiments, there's an important distinction between two different types of experiments. Between subjects' experiments and within subjects' experiments. between subjects is the kinds of experiments I've already been talking about. You get a group, you randomly assign them to 2 or more groups, do something different to the different groups. And what you're doing at the end is looking for differences between the subjects in different groups. And by the way, if you're given no other information in a test or in a psych book, normally assume that they're talking about this kind of experiment. Between subjects are kind of the more standard type. In some cases, we can do what's called a within subjects experiment, where there's just one group. And the group will do both levels of the independent variable. And then you can compare look for differences within each person. Did they do better or worse when they were doing the first level of the independent variable or the other level of the independent variable? If that sounds really abstract, we'll make it concrete. You will all now, if you are willing, participate in a within subjects experiment. We're going to do a little memory experiment. Here's the way it's going to work. In the first condition, I'm going to read to you a series of word pairs, and I want you to say the word pairs audibly in your head. So, for example, if I say jar hammer, just say in your head, jar hammer. Okay, straightforward enough? All right. Zebra, jeans. Banana, moon. Chocolate, textbook. Toe, ketchup. Insect, scientist. Thermometer, knife. Box, chair. Can, pepper. Okay, so now I'm going to read the first word of each of the pairs, and you're going to write down the other one if you can. So just make a list of 1 to 8. We'll go through it. So number 1, zebra. So write the other word if you remember it. Number 2, banana. Number 3, chocolate. Number 4, toe. Number 5, insect. 6, thermometer. 7, box. And 8, can. Okay, now I'll give the right answer so you can mark it and then total up how many you got right on this one. Okay, number 1, jeans. 2, moon. 3, textbook. 4, ketchup. 5, scientist. 6, knife. 7, chair. And 8, pepper. Okay, so that's condition 1. Condition 2, same basic idea, but this time, instead of memorizing via saying it in your head, you're going to form a visual mental image. So I want you to, let's say the words were jar and hammer, visualize a hammer in a jar, or something like that. Some visual thing with the two things together. Okay? Cow, shoe. Dog, dress. Apple, toilet. Boat, tree. Table, baby. House, backpack. Fridge, coat. Microwave, grape. Okay, same thing, 1 to 8. Number 1, cow. Number 2, dress. Oh, sorry. I said it wrong. Okay, well, I'll fix that then. Number 2, dog. Number 3, apple. Number 4, boat. Number 5, table. Number 6, house. Number 7, fridge. And number 8, microwave. Okay, these are now both out of 7, so cross out number 2 for both of them. So if you got number 2 right the first time, subtract that from your score just to make this fair. So obviously I said the second word for one of them. So number 1, cow, the other word is shoe. Number 2, obviously the word was dress, we'll just cross that out. Number 3, toilet. Number 4, tree. 5, baby. 6, backpack. 7, coat. And 8, grape. Okay, so add them up and total them now out of 7. So ignoring whatever you got on the second question for both. Now look at which one you did better on. Show of hands, who did better on the first one? 2 people. Who did better on the second one? Right. So I've done this many times, that's what happens every time. So that would be an example of a within subject experiment. The independent variable, actually let me ask, what is the independent variable in this experiment? So what's the variable that I manipulated between the 2 conditions? Speak up.
What we're thinking of?
Sort of, yeah. Well, are you thinking visually or auditory? So you could say memorization strategy or something like that. That's the thing that I manipulate between the 2 conditions. What's the dependent variable? Words remembered. Right, so the dependent variable is the thing you measure at the end and the thing that you think is affected by the independent variables. In this case, memory, number of words remembered. That's what the dependent variable would be. Now, there's a few problems. There's one big problem with the way I did this. Can anyone tell me what the big problem is?
I knew I was gonna have to remember like the second word the second time. I already have done it one time.
Exactly. You've already done it one time before, so maybe you did better because of visualization, or maybe it was because of practice. You've already done this once before, and you know what's coming. Some people did worse the second time. Maybe they did worse because they were bored. They're like, I hate this class and these games. So you don't know if it's the independent variable that caused the difference, or the fact that you had practice, or you've done it before. So if I was going to do this properly, I would do what's called counterbalancing. This is only an issue when you're doing a within subjects experiment. Counterbalancing means you would make it so that some people do it in one order and others do it in the other order. So if I was really going to do this carefully, I'd randomly assign half of you to leave and come back and do it in the opposite order or something like that. So that's what you do to control for order effects. Any questions about the 2 types of experiments? Okay. A related issue is the 2 types of validity in the context of whether you did your experiment properly. So earlier we talked about construct validity. Is the test measuring what it's supposed to measure? But here, the validity has to do with not measurement like a test, but did you set up your experiment properly? And the 2 types are internal validity and external validity. So let's start with internal validity. Internal validity is about within your experiment, forget about the real world outside of the lab where you're doing it, how confident can you be that the independent variable caused a change in the dependent variable? So I randomly assign people to two conditions. Let's say it's a drug. So the independent variable is antidepressant versus placebo. The antidepressant people are happier at the end. How confident can I be that the happiness, the fact that that group is happier, is due to the antidepressant? For whatever it's worth, in real studies, not that much happier. And among moderately depressed people, not happier at all. That's worth. That's for a later chapter, though. So that's internal validity. Now I'm going to talk about the main threat to internal validity. This will make it, I think, more concrete. Let's say the independent variable I want to look at is teaching method. Let's say I have two different teaching methods, teaching method A and teaching method B. For teaching method A, I use it on students in Edmonton. Teaching method B, I try on students from Vancouver. At the end, the Edmonton kids, their average is 83, and the average for the Vancouver kids is 61. And I conclude teaching method A is better. It caused the Edmonton kids to get better grades. What's the main problem with that inference? Yep.
It could have nothing to do with your teaching method.
What could it have to do with?
They're just not as good at school in Vancouver.
Exactly. So it could have to do with differences between Edmonton and Vancouver kids. Maybe Vancouver kids are not as smart as Edmonton kids. Maybe Vancouver kids are more depressed because they never see the sun. Right? Or it could be any number of things, right? So the key thing I'm missing in this case is random assignment. I didn't randomly assign them to the conditions and then do my manipulation. In this case, location, or where the kids are from, would be an example of a confounding variable. This is the main threat to internal validity. And to be more precise, a confounding variable is anything that's different between the two groups other than the independent variable. You want it to be the case that the only difference between the two groups is the thing that you manipulated, the independent variable. So it could be memorization strategy, like in our experiment, or a teaching method, in this case. You want that to be the only difference. Because then, the differences in the dependent variable, you can say, are due to the independent variable. So that's internal validity. How confident can you be that changes in the independent variable cause changes in the dependent variable? Any questions on internal validity? Okay, what about external validity? External validity, so you have your sample that you brought into the lab. Then there's the real world. And you brought your sample in, you found some pattern. How confident can you be that the pattern you found in the lab will generalize to the real world? That's external validity. So you should see why they're called internal and external. So internal is within your study. Did your manipulation cause a change? How confident can you be that that's true? External validity is how confident can you be that whatever you found in the lab will also hold in the real world outside of the lab? There are different threats to external validity. I'll mention two that you should know. One is an unrepresentative sample. If your sample is all white dudes, and you say, this pattern is true of human beings in general, you would have low external validity. You could still have high internal validity. You may have done the experiment perfectly well once you brought people into the lab, but you can't be confident that the pattern will generalize beyond your sample. Another is unrealistic lab situation. Rather than pick on other people, I will pick on myself. In grad school, my main area of specialization was moral psychology. So I studied how people respond to different sorts of moral dilemmas and how that correlates with other traits that we measured. Now, what do I do to measure people's moral tendencies or lack thereof? I give them different moral dilemmas on a computer screen that they respond to. Now, one could charge that's an unrealistic lab situation. When people face moral dilemmas in their real lives, that's typically not how they emerge. And it could very well be that the patterns in responding that I get in the lab will not hold in the real world. So that would be an example of a potential threat to external validity. Any questions on external validity? Okay. The next set of concepts are probably the most difficult in the chapter. These have to do with replication. And in order to explain that, we have to get into the p-value and statistical significance. These are concepts that many professors misunderstand. We've actually done studies on this, and many psychology professors have a wrong idea about what these concepts mean. But the first concept is not hard to understand. It's replication. Replication is very important in science. So let's go back to my area, moral psychology. So I do various studies, find a particular pattern. In order to build consensus, it's not enough for me to do the study. Some other labs have to replicate my results, do the same protocol, include the same measures, and see if they find the same pattern. Maybe I'm biased, worst case scenario, maybe I'm a fraud, maybe I made up my data. That does happen, not me, other people. Or it could be a statistical fluke, we'll see reasons why that can happen. When many labs, including maybe some labs that disagree with the original finding, obtain the same pattern, then you have more confidence that it's a real pattern, not just the result of bias or a statistical fluke. However, and what I'm about to say would not have been in the textbooks 12 years ago. Psychology has been undergoing a bit of a revolution in the last 10, 15 years due to something called the replication crisis. How many of you have heard the term replication crisis? A handful. So, part of me thinks, I shouldn't mention this because it will decrease your confidence in other things that I say. But leaving that aside, it's a very important term to know. In the early 2010s, there was an effort to just get a bunch of random results from different psychology journals, follow the protocol exactly, and see if you get the same result. What you find is that around half of the results didn't replicate. They were unable to find the same pattern. That's bad. So this sent psychology into kind of a frenzy, trying to clean up their act and get results that are more replicable. in order to understand the efforts that have been made, you have to understand the p-value and statistical significance, which the book talks about. So let's talk about the p-value. So I'll build up to it. Let's say you're looking for a sex difference, some difference between males and females in some behavior or psychological trait. And for fun, let's say you're looking for a difference in video game play. Probably you find one. So there's the population, males and females, but we can't ask all of them, that's too much work. So we get a sample. Sample of, let's say 1,000 males and 1,000 females. And we ask, how many hours of video games do you play per week? And let's say, and probably wouldn't be decidable, let's say the average for males is 10 and the average for females is 2 in our sample. Crucially, it's possible that in the population, there's no difference. Maybe males and females in the population play an average of 6 hours per week. And just by chance, we happen to sample more video game loving men and fewer video game loving women. So here's where the p-value comes in. The p-value is the probability of getting the result you got if there's no difference in the population. There's caveats I have to add to that, but for intro, that's good enough. So, just say that again, the p-value is the probability of getting the results you got if there's no difference in the population. The fancy term that you'll see in later courses is the null hypothesis. The null hypothesis is the one that you want to reject. You want to reject it. In this case, it'll be the hypothesis that there's no difference. Now, without worrying too much about numbers, do we think the p-value will be high or low in a case like this? Put another way, what are the chances we would get a difference this big if there's no difference in the population? Is that very likely, very unlikely? What do we think? No one wants to say. Well, I can tell you, it would be very unlikely. If there's zero difference between males and females in the population, and we get a big sample of each, very unlikely we would get a difference that big. If it was something like, 5.6 and 5.7, okay, that's not so unlikely. You could get that just by chance. Just you happen to sample more video game loving people in one group. In a case like this, the p-value would probably be like 0.00, lots of zeros, 1. Very unlikely. And that's good. We want it to be less likely that we would get this result if there's no difference. In science, social sciences, biological sciences, we set a cutoff. And we say if the p-value is below this cutoff, we will conclude provisionally that there's a real effect. Does anyone know what the magic number is? There's a magic number. We want the p-value to fall below. Yep. 0.05. 0.05. So that's the magic number. So we want it to be less than 5% likely we would get the result we got if there's no effect in the population. Now, it's not as though God spoke to us and said, thou must use a number of 0.05. It's kind of arbitrary. We could have picked a different one, but by convention, that's what we chose. So if you get a p-value of 0.06, kind of out of luck for publishing. This led, though, to a kind of bad incentive structure. Because let's say you do a study and you find 0.09, not that far off. There are various researcher degrees of freedom, different decisions that researchers have to make, and there's not necessarily a right or wrong answer with which thing to do. So one thing you have to do when you do surveys or studies in psychology is exclude some people. So when I did surveys at the U of A, our rule was we would exclude people who took less than 5 minutes to complete the survey, or more than, I think, 2 hours. More than 2 hours, you're obviously clicking in and out of it, you're not paying attention, we're gonna cut you out. Less than 5 minutes, you must have been going much too fast to take it seriously, so again, we exclude you. Again, we could have made it 6, could have made it 10, but we just decided upon that. But in the old days, sorry, my computer logged out. In the old days, researchers would play with decisions like this. So you might have the cutoff be 5 minutes, and then look and you get 0.07, and you think, maybe 10 minutes is better. 10 minutes is still pretty fast, takes me 20 minutes, and no one has to be dishonest or deceitful. These are decisions you can make. You try this a few different ways, maybe add a covariate, do a different kind of statistical test. And let's say with one of them you get 0.04. Which result do you write up for the journal? The 0.04 one. The problem is if you do this enough times, eventually you're almost guaranteed to get at least one result that's statistically significant. Statistically significant just means the p-value is below the cutoff, below 0.05. So nowadays, it's much harder to get away with that because of a growing emphasis on what's called pre-registration. So if you do an honors thesis here, or go on in psychology, you'll see this term a lot. Pre-registration means you say in advance, this is the hypothesis I'm testing, this is the statistical test I will use, and these are the people I'll exclude. You kind of bind your hands. You say, this is how I'm going to test it. And you have to publish it in a kind of a website that doesn't allow you to change it later. Now, you can still try other statistical tests afterwards, but you have to admit, this is not what I was originally predicting. I kind of tried some other stuff later, so take this result with a grain of salt. And then probably you'll be asked to replicate it with another pre-registration where you say, I'm going to try this again. So nowadays, if you want to get published in the big journals, you often are required to do that. Okay. Any questions about replication, the p-value, this set of concepts? Okay, next, two different types of errors. So you'll talk about this in more detail if you take a statistics class, but I'll keep it simple for us. So there's two things going on. There's the true state of the world with regard to your hypothesis. And there's your decision based on the evidence you gather in your study. So let's say your hypothesis that this new antidepressant is good. It's effective at reducing depression. So there's the true state of the world, that God knows or whatever. Either your hypothesis is right, check mark, or X, it's wrong. You don't know for sure whether the drug works or not, but you want to find out. You get some people, you do your little experiment, and you come to a conclusion based on the evidence. You either conclude, yep, my drug works, or no, it doesn't work. So now there are two different types of errors that you can make. So obviously if you're in these two, then you're good. If you conclude this drug is a piece of garbage, and it is in fact a piece of garbage, you've made the correct decision. Same here, you conclude the drug works, it in fact does work, you've made the right decision. if you are here, so the drug in fact does not work, but you've concluded that it does based on your study, this is called a false positive. So the positive bit has to do with what you decided. It doesn't make sense to say the world is false. That doesn't mean anything. But your conclusion can be true or false. So you said the drug works, but in fact it doesn't, so that's a false positive. Also called a type 1 error. Same thing. If you're in this bucket, that's a type 2 error or a false negative. So you concluded this drug, it's no good, but in fact it is good. Maybe you didn't have a big enough sample to detect the effect, or there can be different reasons why, but you conclude the drug doesn't work when in fact it does. As a trick for later classes, if you have trouble remembering which is type 1 and which is type 2, I would just imagine the first line for the type 2 rotating into a minus sign. That was the little trick I did. So it's like -1. If that works for you, you can do it. So 2 different types of errors. Any questions about those? Okay, good. We're nearing the end. We'll probably have a little bit of extra time. Okay, so there's then a section on critical thinking. Some of this I've already anticipated with different comments I've made. One type of bias that exists, it relates to the idea of confirmation bias that I brought up earlier. We react to evidence very differently when we want to believe something than when we don't want to believe something. When we want to believe something, the question we ask ourselves is, can I believe it? Can I find some evidence or some support for the idea? And the answer is almost always yes. There's usually some support you can find for an idea if you look hard enough. So when we want to believe it, we ask, can I believe it? If we don't want to believe something, we ask ourselves, must I believe it? Is the evidence so strong that it forces me to believe this? And the answer there is almost always no. You can almost always find some wiggle room. Evidence is, especially in social science, is rarely so overwhelming that it forces you to a specific conclusion. One way this expresses itself is when you get people to read 2 studies. Let's say one study that supports their belief and one that goes against it. When they read the study that goes against their belief, they take longer to read it and read it more carefully, trying to find a problem with it. And usually you can find something. No study is perfect. The way to counteract that is to criticize both. Try to criticize everything you read. That's what it means to think critically. Don't take anything at face value. A related term, which Sean Carroll mentioned, is skepticism. Skepticism relates to doubt. Right? Don't things at face value. Don't take things on faith. When you're playing the scientific game, you should follow the advice of the Royal Society. So the Royal Society was one of the first scientific societies in the world in the UK. And they had a mantra, a slogan, nullius in verba. Take no one's word for it, is how it roughly translates. And that's a good kind of summary of the scientific mindset. Don't just assert things, but show me. I'm not going to necessarily trust you right away. I want you to convince me with evidence. Okay, last section is on research ethics. So nowadays, if you want to do any study in psychology, even if it's something as simple as a survey, you have to run it by an ethics board at your institution. So at the University of Alberta, when I did my various studies, every time I would have to submit it to the ethics board. This emerged because of various experiments in psychology that were, let's call them ethically questionable. Some of these became very famous. How many of you have heard of the Stanford prison experiment? That's a pretty famous one. Have any of you heard of the Milgram experiment, the electrocutions? Slightly fewer, but some of you have heard of that. So for those of you who don't know, I'll show a video with some clips of each. So we'll discuss these in more detail in the social psychology chapter, but the Stanford prison experiment, Phillips and Bardo set up the basement of one of the buildings at Stanford to be a prison. People were randomly assigned to either be guards or prisoners, and the guards became pretty coercive and abusive towards the prisoners. They wound up canceling the experiment early. So nowadays, that would never fly with the ethics board. The Milgram experiment involved people being led to believe that they were electrocuting people, and they were told to electrocute them every time they got a wrong answer. And you hear like screaming in the background and eventually silence. Now, in fact, it was an actor, but as you'll see, pretty convincing. So these are the kinds of things you wouldn't get away with now. But as I said, I'll show some footage of these two famous experiments, which we'll look at in more detail. Okay, we'll see some more footage of that in the social psych chapter. Anyways, that was the impetus for starting these ethics boards. I think it's very good that these ethics boards exist. However, I will note anecdotally, they drove me crazy. People, I think, need to feel that their jobs are important. So what they did in practice was waste a lot of my time. So, for example, one time I submitted an amendment saying, I ran out of time, I need more, I want to extend it 2 months so I can collect more data because the time had passed. And they said, no, you have to provide more reason for why you want to extend the time. I was very tempted to write because people can't time travel if the date has passed, but that's just an aside. So what are the kinds of things that ethics boards look for when they're not wasting my time? One thing that's required, as Hank Green mentioned, is informed consent. So when you do any study, if you do it here at Douglas, for example, you'll be given a consent form that will describe the basics of the experiment, and you have to give your consent. And even still, you have to be free to leave at any time. You can't force people to stay in the study. You should protect participants from harm. There should not be more harm or discomfort than what people encounter in everyday life. So some aspects of studies may make people uncomfortable to some degree, but it shouldn't exceed what they're normally exposed to. And any harmful, potentially harmful bits you have to mention in the consent form. So in my own work, I have to include a line in the consent form that the study will involve thinking about things that may be unpleasant. So that I'm going to give them moral dilemmas that may involve thinking about death or other things. We are allowed to engage in deception in psychology. So you can mislead participants about what the study is about, even after studies like the Milgram one. So as an example, I also did some studies on confirmation bias, but I didn't want people to know that, so I led them on that it was a study about memory. Because I didn't want people thinking, ooh, how biased am I being? I thought that might mess it up. That's actually pretty common. However, if researchers do that, they have to mention that in the debriefing form. So at the end of every study, there's a debriefing form which will say what the hypothesis was, why various items were included, and sort of apologize for any deception that they may have engaged in. So we told you it was a study about memory, it was actually about confirmation bias, here's why we told you that. So that's ethics vis-a-vis human research. When it comes to animal research, the rules are much looser. You can get away with pretty unspeakable things vis-a-vis animals. You know, if you take 1100, you'll know that, or it might not be covered there, but certainly if you go on to take upper level neuroscience classes, researchers will often destroy parts of animals' brains just to find out what those parts of the brain do. Actually, that reminds me, I think I might have missed a term. Yeah, so one term I missed that I'll mention now, apologies, is case studies. So when it comes to human neuroscience, we typically use, I should say often use this method. So if we want to know how the animal brain works, we can destroy different parts of their brain and then look at what the animal can't do anymore. So if the animal can't do short-term memory tasks anymore, we infer that that part of the brain was causally implicated in short-term memory. With humans, the ethics boards will not let us do that, very sad. So what we do is we let people hurt their brains on their own. As you all know, sometimes people do foolish things that damage their brain. That's very convenient for the neuroscientists. They come into the lab, we obtain their consent, and we can give batteries of psychological tests and find out which functions have been impaired by damage to that part of the brain. So, I should say, case studies are any studies where you study one person or a small number of people in depth. Typically because there's something special about them that means they'll give you good information. So in neuroscience, often we do this. We'll take one person who has a particular kind of brain damage. So one case you'll learn about 1100 is Henry Molaison. And if you remember Henry Molaison, or HM, so he's the one who had the hippocampus removed because life-threatening seizures were emanating from there. And he lost the ability to form new long-term memories. So, pretty reasonable inference, the hippocampus is involved in generating new long-term memories. So, I should have said that earlier, but just keep it in mind. But with animals, you can destroy the brains just to find out what they do. The ethical constraints are, you have to be as humane as possible, so use different pain reduction techniques insofar as that's available. And it should be that there's a clear scientific purpose for doing it, although there don't need to be clear health benefits to society or anything. You can harm animals even if it's just to figure out what the frontal lobes do or what have you. This is obviously controversial. The book has a discussion of different philosophers and ethicists who have argued that we should have stricter requirements for animals, but of course this is an ethics class, but that is discussed. The final thing, which should be obvious but is very, very important, is respecting truth. This is maybe the most important ethical ideal. Don't deceive, don't fake your data. Should be obvious, but some people still can't manage to pull it off. There's a famous recent case in the United States. Did any of you hear about Francesca Gino at Harvard? Any nerds who follow? So it's quite funny. She faked data in a study about dishonesty. If you wrote it as a book, it would seem unbelievable, but sure enough, she was fired for it. Hopefully this video doesn't go viral because she sued Harvard for it, but subsequent investigations made it pretty clear that she in fact faked her data. Okay, that is all I have for chapter 2. Any last questions? Okay, if you're on the wait list, come give me your name, I'll keep it in mind. Next week we'll talk about emotions. And if you're on the wait list, still keep checking